So hi students, welcome back. In this chapter we will deal with the term slope, we'll understand its meaning, we'll go through the practical examples and then do a mathematical formulation to go into the deeper of straight lines. When we have done all of this, then in the end we'll try to see the property of reflection using the terms of slope. So stay tuned for all of this. So let us start with the locus definition of straight line. How do we define straight line in terms of locus? A straight line is the locus of a point whose coordinates satisfy a linear equation. So let us try to understand it mathematically. Suppose we are trying to find out a locus, and if that locus comes out of the form ax plus by plus c equals to 0, let us see the powers. The maximum power of this x is 1, maximum power of y is 1. So all the variables have the power as 1. So that is why this is a linear equation. And because it is consisting of two variables, and two variables are generally used in two-dimensional geometry, hence with this definition this is going to be the general equation of a straight line, where a, b, c are going to be the constants which can take any value, and x and y are the variables. X is the variable that is change in the x-axis, and y is the variable that is the change in the y-axis. So next we will define a term which is very important in determining the final format of a line, that is slope. Let us first of all understand its concept. How do we generally define and what do we mean by slope? The pictures on this wall you can see is the various practical applications of slope, and it will help us in understanding what is slope. As we know that slope is nothing but just y by x. It is the vertical motion covered while maintaining a specific horizontal distance. This is a sprinter which is running on a horizontal ground. This picture represents a friend pulling up his friend to the upward direction, where he is doing both the motions, horizontal as well as the vertical, and this is the very famous Leaning Tower of Pisa. So let us grab the concept. As the sprinter is running on the horizontal track, so she is not doing any vertical motion because she is running on a horizontal track, so there will be no slope for this. But this is vertical as well as horizontal motion, so there will be slope, and with respect to this sprinter it is written as more slope, and the Leaning Tower of Pisa will have even more slope, right? So let us move on to the quantification of the values. That is done is how many steps up for one forward. Suppose you are moving one step forward in the horizontal direction, how many steps you have moved in the vertical direction, that is the quantification of slope. For this sprinter, she is not doing any vertical motion, so the numerator part is 0, that is why the slope is going to be 0. For this, both the guys will have considered that the scale on the x and the y axis being equal, so that is why the slope is considered to be 1, because change in y is equal to the change in x. And for the Leaning Tower of Pisa, we have given it a value greater than 1, just to give it a symbolical form, because it is more curved as we can consider this. So next we are going to do the mathematical formulation of slope. So this is the definition when the theta is given, that theta is the angle which the line is making with the axis. So this is the figure that is going to look like, and in this x dash ox is the x axis, y dash oy is the y axis, and this is the line that we are considering. How do we generally define slope? Slope is nothing but the tan of the argument, and argument is measured in a specific sense. Argument is always measured from the positive side of the x-axis and in the anti-clockwise sense. So this term includes two different subterms, so we will have to understand its meaning. Suppose you are considering this point where the line is intersecting the axis. So the point which will lie on the right of this will constitute the part of the positive side of the x-axis, and with respect to this point, the points which are going to lie on the left hand of this will constitute the negative side. So the line is making an intersection with the x-axis at this point, but at this point we can measure two angles. One is this theta 1, and this is considered again the theta 2. But you can see that sense of the measurement of angle in this is clockwise because clock takes in this direction, and the sense of measurement for this angle is in anti-clockwise against the motion of the clock. So the tan of the argument will be the part which is being measured from the positive side, and that too in the anti-clockwise sense, and the correct representative for that is this. So slope of this line as generally defined by the value m will be nothing but the tan of theta. So this is how we have defined that slope is tan of theta. And from the previous picture, what I have said is y by x. Y is the number of steps in the vertical motion and x is the number of steps in the horizontal. So this is horizontal in the denominator part and this is the vertical. As you can see in the picture, it is saying the number of steps up that you have moved in the vertical direction, and this is the number of steps in the horizontal direction will give you the mathematical value of the slope. And the most important thing is the value of theta, which is always measured from the x-axis. Next in the series is the various values of slope and consideration what will be the value of theta. If the slope is positive, tan theta is acute. How we can say this? Because we know that slope is tan of theta, and if tan theta is positive, so the range of theta will be less than pi by 2, which is an appropriate condition for an angle to be acute, hence very true. If slope is negative, theta is going to be obtuse. From the same analogy, we can say that if tan theta is negative, theta will come under the second quadrant, which will constitute theta to be obtuse. Now, as we all know that tan theta is sine theta by cos of theta, so let us consider the next two parts. The next part says if theta is 0, then we can say slope is 0, or vice versa. If slope is 0, then we can say theta is 0. So let us see it mathematically. If tan theta is equal to 0, which means the value of this is 0, so I can frankly say that sine theta has to be 0, and a very appropriate answer when sine theta is 0 will be 0 degree. Hence, if slope is 0, I can reversibly say that theta is 0, and if theta is 0, I can say that slope is 0. See, but there is a crucial point. What will happen if cos theta becomes 0? That is the next case. If theta is 90, then what will happen with the slope? If theta is 90, the cos theta, that is the denominator part, will become 0, right? And if denominator has become 0, so something constant upon 0 is infinity, and that is not a number. We cannot quantify infinity. So what does that mean? The slope is infinite? No. If the theta is equal to 90 degrees, slope is not defined for that kind of line. And a very practical example for the last two cases will be, the first case will be the line parallel to the x-axis, because there will be no vertical motion in this line, and theta equals to 90 will be this line that will be perpendicular to the x-axis. And it is a very general value that slope is usually denoted by the term m. Now we'll talk the value of slope in terms of 2 points on a line. So for this, we at least need a line and 2 points on that. So this is the figure which clearly shows the expected scenario. This is the point number 1 and this is the point number 2. So these are as again the x-axis and the y-axis. So let us define the slope in this figure. Tan of theta, see, this is the theta which the line is making with the positive x-axis, and that too in the anti-clockwise sense. So yes, this is the correct representative for the argument of tan, but this is theta. Then I need vertical motion upon the horizontal motion. This is what is my requirement, right? So I can say that Qn is the vertical motion and Pn is the vertical motion, which in turn is equal to the Lm. Okay, so now we will define the values for Qn and Pn. See, this topmost point, the y coordinate or the ordinate of this point is going to be y2, no doubt in that, and the ordinate of the point N, which is in straight line to the point P, will be nothing but y1. So the requirement which we have over here will be nothing but the difference between these two. So this will be y2 minus y1. So based on the same analogy, I can say that O to L is x1 and O to M is x2. Hence, LM is going to be nothing but x2 minus x1. Right? So LM is nothing but x2 minus x1. So this is how we are going to define the change in the horizontal direction, and this is the change in the vertical direction. So this will be the slope y2 minus y1 divided by the value x2 minus x1, which in terms of language can be written as the difference of the ordinates and the difference of the abscissas. Now the result which we will obtain from this, the slope of reflection in either axis, can be used as end result in numerous problems that have been coming in the JEE Mains and JEE Advanced. Let us get to the core of this concept, what this concept has to teach us. It says that slope of a line is equal to m, then the slope of the reflection will be nothing but minus m. So at least we are engineers, so we need not believe anything just by saying, we'll try to prove it. Suppose this is the line L1 and this is the line L2, and L2 is reflection of L1. Okay. So if L2 is reflection of L1 and L1 is being given to us, so this is the theta which will come for the tan. So suppose M is tan of theta. As this line is the reflection of this line, so you will agree with the fact that this triangle MNP, triangle MNP is going to be the isosceles triangle with MN equals to NP, because it is nothing but the reflection. So these two angles are going to be equal, and from the concept of linear pair, I can very specifically say that this angle is nothing but pi minus theta. Hence, if this is pi minus theta, so this angle pi minus theta. So the slope of the line L2, so slope of the line L2 will be nothing but tan of pi minus theta. And from the coordinate knowledge and trigonometry knowledge, I can say that this will be nothing but minus of tan theta, and that is minus of n1. See how this is, we get the proof that if slope of a given line is m, then the slope of its reflection is going to be minus m. So in this part, we have seen the meaning of slope, its application in the straight lines, and the various practical examples. In the next coming part, we'll see the angle between two straight lines. So keep watching and be there.